Well, hello everyone, and welcome back again to AWS OnAir Data Dive. This is the show where we dive deep and get those shiny data treasures for you. As always, my name is Aditya Samant. I'm your host, coming live from sunny and warm Dallas, Texas. At least I think it's sunny and warm outside because they don't really let me out that much. Today's topic is really interesting. It's about upgrades. Aurora MySQL upgrade specifically. Back in the day when I was a DBA, I used to think to myself, boy, wouldn't it be neat if I were to upgrade a database today? Well, that's a lie because I never used words like neat. Neither did I want to upgrade databases. But regardless of the pains of upgrades, we know that there are lots of goodies when you upgrade a database. And that is the topic for today. We are going to talk about how to get yourself from Aurora MySQL 2 to Aurora MySQL 3, and how to make most of it. Of course, I'm not an expert at all. I'm just here to make those funny, humorous comments and make everyone look good. But to tell you more about upgrades, we have my colleagues and friends from our worldwide specialist team, Shagun Aurora and Simon Comendera. How are you guys feeling, folks? Feel like dropping some knowledge about upgrades on everyone?
Yes, and learning from everyone.
Excellent. Well, Shagun, why don't you go ahead and introduce yourself real quick?
Yeah, sure. Hi, everyone. Thanks for dialing in. My name is Shagun Aurora. I wish I could say that the Aurora product was inspired by my last name, but that's not the case. I'm going to be talking about upgrades today. That's one of the common topics I talk to customers about these days, and then learning from them while I make these discussions. So happy to be here.
Awesome. Simon?
Hi, everyone. Thanks for being with us here today. I'm Simon Comendera. I'm a Principal Database Specialist Solutions Architect for Aurora. It's a bit of a long title, but shorter than the nice and juicy demos and presentations we have for you today. So let's talk about upgrades. It is a hot topic. We have not only knowledge, but also really practical demonstrations for you today. So hopefully this will be interesting throughout.
Excellent. Yep. We are going to have some fun today. We are going to see some demos. Both Simon and Shagun have created a bunch of demos for us, so we'll keep it interactive here. So, Shagun, tell me, if I am on Aurora MySQL 2, my life's good, I'm a DBA, I'm SRE, why should I upgrade? I don't want to upgrade. It's too much work. Tell me, convince me, please.
Yeah, definitely. No, and that's what we'll be talking about most of the piece today around that topic. And then before I kind of go in, talk about why to upgrade, just as a background for folks who are not aware, in Aurora MySQL world, MySQL 5.7 is what we call as Aurora MySQL 2, and then MySQL 8 is what we call as Aurora MySQL 3. And the reason to go ahead and do the upgrade is, as folks may be aware, MySQL 5.7 got its end of life in community back in 2023. And what is happening right now is that Aurora MySQL 2 is also approaching its end of standard support in October of 2024. I say standard support because, as you see on my slide, we do have a provision for customers who, let's say, do not have the
Whoa!
bandwidth.
Your slide's not up. Sorry. Let's
Oh,
get her slide up.
sure.
There we go. There's the slide. All right, start
All
again.
right. Yeah, sure. So, well, this slide just talks about kind of shows the community end of life that MySQL 5.7 received back in 2023. And what's happening right now is Aurora MySQL 2 is getting end of life in October of this year. And for customers who, let's say, do not have the bandwidth to do this upgrade in a few months that are left, you do have the provision to be enrolled in extended support as well, which will be an additional pricing that won't start until November 30th. So kind of staying away from extended support prices is one of the reasons why you should be looking into doing this upgrade. And then there's also a bunch of new things that have been added in MySQL 8, a bunch of cool features that have been added in Aurora. So things like serverless V2, IO optimized, enhanced bin logs, new Graviton instances that are supported. There's a bunch of different things and all these features that we're going to continue to talk about in the time that we have today.
Okay, I'll hold on to that. I want to hear about V2, optimized, and new. Those are the three keywords I heard. So that's
Yeah.
excellent. So obviously we don't want to pay for that additional extended support, but I think it's nice that it's there if you need it, right? So what are the challenges of upgrade? Like, I think I'm convinced like there's new stuff coming out. There's some things that are optimized, things that are new, things that are better, faster. Um, but what are the challenges? You said you work with customers a lot, right? What do our customers commonly see when they have to upgrade?
Yeah. So coming back to my Google Chrome window, and what's happening here is, so firstly, I'll show you some pre-upgrade checks that are going to be kind of very helpful for customers to get ahead, understand if there are any incompatibilities, any things that they need to change before they do the upgrade. So I'll talk about that. And then those are also going to be some of the things that they should be aware of. If a customer, if you have, let's say, hundreds of Aurora clusters, you're not really sure which one do you have to upgrade, you can, in your RDS console, click on this recommendations tab. And then this is the point where it kind of points out all the clusters for you where you need to do the upgrade. And on the top, it also says that if you do not do it by that deadline, this is where I said that you will be auto-enrolled into extended support.
But this is good though, right? I mean, what was it? If you don't do it by this date, we'll do it for you.
Yeah, yeah,
That was kind of the thing before, but now we're saying, well, you get to stay, but hey,
yes,
it'll probably cost you. So I don't know
yeah.
which one's better. I think this is better, but
Yeah,
folks may have other opinions.
yeah, no, this is definitely better because it allows you to have business continuity and again gives you that freedom to decide when you want to do the upgrade. But let me go ahead, talk more meat now, and show you those upgrade pre-checks. Now, what is happening here is why do this matter is because, and let me increase my font size here. So what's happened is between MySQL 5.7 and MySQL 8, there have been a lot of changes that have been made. Some of them are bigger changes. So things like there's a new data dictionary in MySQL 8. Some of them are more smaller changes like new keywords that have been reserved, some have been deprecated. There are changes in default values of parameters. So overall, a bunch of different changes. How do you want to kind of know about it? Not one person can know it. That's why I'm going to show how you can run these pre-checks. There's two methods of doing that. One I'm going to show you is MySQL pre-check utility. It's the upgrade checker utility. And this is how the command for it looks like. What I'm doing right now is I have my EC2 instance. I've installed my SQL shell on it, and I'm running this command. And what are the different arguments? You put your master username, you put your Aurora endpoint, your cluster endpoint, and then I have my password. Um,
I love it. It says password. That's the best password in the world. That's what I use it. Please don't use my social accounts to hack, please.
So you put your password and you put your target version in here. For target version, if you are confused on which target version do I choose, we have our handy Aurora documentation. It talks about all the versions. You can look into release notes of each one to try to see which are the new features that you want to go to.
Yeah, that's cool.
All right,
So,
so yeah.
go ahead. There's still demos going on. Sorry. Go
Oh,
for it.
no, no problem. All right. Okay. So this is my command. Once this is ready, you go ahead and run it. And this will take a few seconds to run, but this is how the output looks like. Pretty extensive output, but you can, make a file of it, a text file of it, and look at it more carefully. But first, let me start with the easy stuff. What is not an issue? So anywhere you see empty square brackets where there is detected problems, that
Yeah.
means there are no detected problems. So this is the stuff you do not have to worry about.
Okay, so we're looking for empty brackets.
Yes. And the other thing is there are going to be some things that you can safely ignore here. I have an error that community MySQL is saying there's a table, it's not looking good. It's the MySQL RDS heartbeat table. Now, because community MySQL is not aware of Aurora and RDS, as a managed service, we are running a bunch of things to do active health checks for you. So some of these errors, that come up with these tables that have RDS or Aurora as a prefix to them, these can be safely ignored as well.
Yeah, makes sense.
All right, now let me show you something where work is going to be required. I talked about reserved keywords, new keywords that have been reserved, and it looks like I have a table with the name except, and except is a reserved keyword. You can find the full list in MySQL documentation to be aware of it, or run this pre-check like I'm showing. And what I have to do here, it also kind of talks about the description. What I have to do to get rid of this is either alter my table or the column name where you're using that reserved keyword, or you can also add quotes and then continue using it. But these are going to be the things that you should be looking at before doing the upgrade.
Okay, so if I call a table, it will get caught here.
Yes, it will. And these are all, again, community pre-checks. What happens with little bit differently with Aurora is Aurora runs these community pre-checks, but then we also have pre-checks that are Aurora MySQL specific. You can find more details in our documentation, and we'll share a link of it in the chat. But now, how do I run these? So in order to run these, what you can do is you take your database that you want to upgrade. This is the one that I'm looking to upgrade. It's currently at version 5.7. When you go ahead and try to modify the version by just providing the target value that you want to go here, in case there are any errors, the upgrade will not succeed. And what you are going to get is a log file that's going to give you a bunch of errors. So how it looks like is, let's say this is one cluster that I was trying to upgrade. Now let's see if it did upgrade. I still see it's Aurora MySQL 3 it's called. And if I go into events, I tried to do this a few days ago. And let me show you how the events look like. It says database cluster is in a state that cannot be upgraded. Look at this log file. So this
Yeah.
is the second way in which you can run pre-checks for you. I showed you the community version. And now with this log file, you can find it here in your console. If you look under logs, you can view this file from here and then download it. I've already downloaded it. So let me show you it in my terminal here. I'm going to look for errors first. And if you see here, there's a new error that I didn't really see in that other output I showed you. And that's exactly why the importance is to kind of look at this file as well, because Aurora is again doing its own pre-checks. What has happened here is it looks like there was a table. I at one point had created a full text index. I have since then dropped it, but the metadata on the table is still not cleared. So
It's
what I have to do,
dangling. The full
yeah,
text index is dangling. I
what I have
like
to
that.
do here to resolve is to just run optimize table, and that's going to fix this issue. But anytime, the key thing to remember here is anytime there is an error, that is what you need to look at priority. Similarly, I can also look at warnings, but warnings are not really going to be the things that are going to stop your cluster from upgrading.
Yeah.
So in here, I have the same warning I showed you guys. This is another one. It talks about whether null values can be accepted in your date columns or not. But overall, have a look at warnings, try to get rid of them, but errors is the one that you should be mostly focused on.
Yeah, so it sounds like you could run the upgrade check tool to get rid of most of the errors and warnings,
Yeah.
right? And
Yes.
then hopefully it catches everything, but there might be a few here and there left that you will catch at the maybe create a clone or something like that. Okay,
Yeah.
so that's great. But I know that lots of customers can't actually take downtime. It sounds like there will be some downtime. Simon, what can these customers do if they want to upgrade but can't have any substantial downtime? Because I know that downtime during upgrades, you may have to take minutes, if not sometimes even hours of downtime. What can we do?
Yeah, and especially for major version upgrades where, like we just saw, there could be things that aren't exactly right. You have to correct before the upgrade can go through successfully. Um, Basically, what we're doing here is still enabling folks to use this standard, sort of industry standard blue-green approach through a managed feature, so that you don't really have to know anything about setting up blue-green environments or replication or anything like that. So basically, try to do it the best way possible with a very, very short switch over period, while basically maintaining full control over the upgrade and kind of abstracting the any sort of risk or any work that goes into correcting those pre-checks or making the upgrade as fast as possible. So basically, and I think Shagun can tell us a little more about the blue-green stuff, but the concept is it doesn't matter how long the upgrade takes. It doesn't matter, if it takes 10 minutes or 10 hours, if it's an extremely complex database. With Blue-green, you abstract all of that outside of your sort of downtime window, and all you have is a very, very short switchover in your Blue-green environment. So I think Shagun can tell us what this really looks like.
Yeah, I think so. It sounds like blue green is basically just a fancy way of saying create a replica, upgrade it, and failover or switch over.
Basically.
But essentially, it's all been managed for you. So I know customers used to do that in the past, called it rolling upgrades, replica upgrades, whatever. But it seems like it's more managed for you. So Shagun,
Yes,
do you have a
let's,
demo on this? We want to see a
yeah.
demo.
Yep. And let's have a look at it, just a kind of a picture. We talked about you about something. So how do you kind of look at it? I'm sharing my slides, and hopefully you can see that slide in here. Um, but this is exactly how it's going to look like. You have a Aurora cluster. Let's say it has two replicas today. You go ahead, very easily click on a few buttons. You are able to create a green cluster that will have that same setup. At this time, you can choose to upgrade the green cluster as well. The one cool thing we have here is the blue and the green are kept in sync using the MySQL bin log replication. And then once you do the switchover, once you have tested everything, everything looks good, you've done the switchover, you now want to promote the green cluster, there are no changes that have to be made on the application side. And that's again a very cool thing, because what we are doing internally is we are also renaming your endpoints, which means you do not have to go into the app again and put new endpoints on there.
So the application doesn't know.
Mhm.
I think it may have to recreate the connections, maybe.
Yes. Yeah. So during the switchover, there will be a small downtime depending on the switchover timeout that you selected, and then after that, connections will be reinitiated on the green cluster. But let me show you a cool demo on this and kind of show you how easy it is to get started with the blue-green deployment. Um, I have my same cluster here, 5.7. When you are here, you can go ahead and click on Actions and then click on Create Blue-Green Deployment. We do not really have a lot of options here. It's pretty simplistic, but all you do is kind of provide a name. I'm going to say something, test blue-green. Uh, this is where you can then select your target version. You
Also,
have
you
an
can actually
option.
upgrade as you
Yeah.
create this blue green. That's fantastic. Yeah,
Yes, so
cool.
you can choose the target version that you want to go to. And then, I also have a provision of not choosing and just being on the same version. And if folks are thinking, well, why would someone do that?
Yeah.
The reason for it is because Blue-green isn't just meant for your upgrade testing. You can use this feature for things like schema changes, parameter changes, basically any test or anything that you want to do in your database. You don't want to do it in production first. You want to do it in a safe environment. You can go ahead and create blue-green for those use cases as well.
Nice. Well, so I just want to call out someone named Robert Tables. What an appropriate name. Actually, won the a little mini contest we had, or a poll question. Congrats, man.
Oh, that's pretty cool. Congratulations. All right, so here I choose my version, and then I have parameter groups to select. There's an option here. If you do not want to select a parameter group, default parameter groups will be applied. But if in your Aurora 2 clusters you were using customized values for some parameters, go ahead and create a similar group for your version 8, and you can go ahead and choose it right here. And once you're ready, it's going to give you an estimate of the pricing. Once you're ready, you just click on this button, and that's pretty much it on how you create the blue-green deployments. The one thing that you should be keeping in mind as a prerequisite, like I had said, these blue and green environments are kept in sync using bin log replication. So on your existing cluster, whichever parameter group you have, just make sure to kind of use the row value for bin log format, which basically enables bin logs. And that's really the only prerequisite that you require to create this blue-green deployment.
That's fantastic. So you push a few buttons or click a few buttons, and then you have this like replica that is being caught up that you can upgrade. You can do all sorts of tests, and when you're ready, you switch over.
Yeah.
Doesn't get any better than that.
Yep. And then let me show you a blue-green that's already ready. Very conveniently, we put these labels for you so you're able to see which is your production and which is a new green that has been created. So whenever there's a green coming in, you'll see the words green. Now here's the cool thing. The replication is flowing from blue to green, not from the green to blue. So this is where that testing part comes in. If you want to make any changes here before you do the upgrade, you can go ahead, connect to the green endpoint. You can make those changes once everything is done. This is when you can perform the switchover. So I showed you guys earlier that there was a full text index, like something that my upgrade was not really happy with. And I said that you have to optimize this table to kind of get rid of this error. Now, this is something that I can do on my green environments. So I'm just going to quickly connect to my green. And again, no impact on the blue. This is all happening on my green cluster. But once I'm here, let me get out of the MySQL shell, and let me go ahead and connect to my green cluster. So put my password, which is password,
We all
and
know what the
then
password is.
kind of, let me show you the tables here. So this is where that opening lines table is. And
Yeah.
here's what I have to do. I can run optimize table, and I can provide optimize. So run things like optimize, analyze, essentially do all of that on your green without an impact on the blue. It's especially going to be very handy for customers who, let's say, have larger tables that take time to run things like optimize, analyze. Do that on the green. And then once you're happy with all of it, this is when you can think about doing the switchover.
So this is cool though. So it sounds like when you create this blue green, you can actually make changes to the green. Simon, I wonder what else can we do to make this thing like ready for switchover.
Yeah, basically anything that doesn't break replication would work. The only thing you kind of have to keep in mind is this is binary log replication. So there's actually quite a bit you can do, because this is, logical replication doesn't care about a lot of the changes that you can make under the hood, as long as the changes can still be applied on the tables. You can even change the tables, schemas, not even just optimize them, but there's a whole lot you can do, creating indexes, reorganizing, like even changing column definitions, changing your, cluster characteristics in terms of, versions, storage, minor versions, major versions, patch versions, anything that does not break replication is going to be, is going to work with blue-green.
Can I add more indexes?
You can. Don't add too many though.
Okay. Well, there's a question here. JDS 1681. I hope that's not your birth date. Who says, can I create my own parameter group for 8.0?
Yeah.
Can't I just use the defaults? Shagun, it seems like you're ready with an answer.
You can, right? So you can use the default, but this is where I was mentioning earlier. If you are using custom values for some of your parameters today, you can very easily go into parameter groups and then create a new parameter group, provide a name, a description again, and this is where you would want to select Aurora MySQL and then choose MySQL 8 so that it's compatible with MySQL 8. Use this when you are doing the upgrade or doing the blue-green, so you avoid yourself one extra reboot that would otherwise happen when you're first time applying a new custom parameter group. So this is a way to save that additional reboot and kind of save you downtime.
Excellent. All right. Well, it sounds like we avoided downtime, we upgraded, but Simon, that doesn't absolve people from actually having to upgrade, right? It's still something that you have to do. Maybe not on such a grand scale. What's your opinion?
Yeah, and we're talking about major version upgrades right now, which really are infrequent, right? It's kind of the thing that you have to do eventually, and but it's not something you're going to be doing every day, moving between major versions. So obviously, between major versions, you're going to still have to do routine patching, whether it's for like security patches or is it for new features. If there's new features being shipped in Aurora, we are going to do it using minor versions, which don't take as much work as majors, but it's not like there's going to be zero upgrades in between. So it's actually probably a good idea to talk about how do you do the other types of maintenance outside of major versions.
Okay. Well, it feels like you're setting up for a demo, is that right?
Yeah, and you keep saying that it doesn't get any better than Blue Green, and I beg to differ. It's going to.
Hey, let's see truth's in the pudding, man. If you have something
Yeah,
better
let's
than
see
Blue
how we
Green,
can do it even better. So, like again, major version upgrades. Blue Green is a standard technique. It's a great idea because you're sort of shielding yourself from all the scary stuff or from the duration of the upgrade. But yeah, what do you do in between the major upgrades? You still have there's features and fixes and improvements every minor release that we do, and you're going to want to make sure that the impact for those patches is so low that you don't really care about them happening. Potentially even enable automatic minor version upgrades for databases, which is a very popular option among many customers. So like you don't even plan it as such; it can go through automatically, and so it's important that we don't have downtime for this. So what is the good number for downtime? Obviously, it's 0. So the aptly named zero downtime patching feature that we have in Aurora is something that I can show you now using basically like a simulated app, just to make sure we understand what this really does. So let's see what this looks like. And so for anything like a patch version or a minor version, zero downtime patching is a feature that you don't really have to enable. It's just going to be available by default in your clusters. And so what this does is it allows you to actually upgrade a minor or patch version of the database without bringing down the connection. So like in Blue Green, you still have to reconnect to the new environment. It's a very short window of downtime, but what if you don't even want that? And so what we have here is I basically just wrote a script. It's just a simple Python application that is going to open one connection, and then in a loop, we're pinging the database on the same connection, right? So this is really critical. You can see there's a few fields here. Connection ID, this is kind of one way to show that we're sticking to one connection, not losing our existing session with the database. We also have a session variable, which is basically like a user variable on a MySQL session. We increment it every time we ping the database. And this is another way to show that the session context will be maintained across the upgrade process. We also have an uptime for the database, and we have the version. This is the critical part. And so what's going to happen here is that in about 20, 30 seconds, once the upgrade request actually kicks in, what we're going to see is that we don't get any errors from the application. So again, this is just one connection. We're not opening a new connection every time this goes through. We are trying to use one connection without breaking it. So what you're going to notice is it's basically just going to hold or freeze for a little bit. We'll see how long that takes.
So I'm assuming while this is running, someone is going in the back end and pushing a button that says upgrade without actually creating any sort of blue, green, or anything like that, right? You're just doing in place.
Yeah. So right now it's stopped, right? So I can actually hold it for a second. All we do is we do an in-place upgrade request. No blue, green, no replication, no anything like that. So right now the connection is holding, but we don't have errors. The connection is still technically open. So if you give it, I don't know, 10 seconds, 15 seconds maybe, which is the typical time for a minor upgrade or patch upgrade is in the order of seconds. So let's stop it here, see what happened. It went through. And so you can see here, well, it took 13 seconds to do the upgrade. We didn't lose the connection. Connection ID stays the same. We didn't lose the session context, all the variables and all that stuff, here stays the same. We did technically restart the database, so the uptime actually reset, which is one good way to see, if there was an update with zero downtime. And the coolest part is really the version change just under the hood without the connection ever like dropping.
That's
So we
fantastic.
managed to
So
do a
so the
upgrade.
version changed. Your session variables didn't change. Your connection ID didn't change. So it's almost like for the application didn't even know that there was an upgrade under the
It's just a
covers.
hiccup. It's just a hiccup, which takes a few seconds. So this would typically not interrupt your application flow beyond a few seconds of like a visible freeze. Maybe if you're running a query, that's all there is to it.
That's amazing. Except I'm guessing, except for their connections or sessions that are actually doing something. So if the database is taken underneath of them, then
Yeah. So the way this works is we try to find behind the scenes in the database engine. We try to find an extremely brief period of time with no activity, which it doesn't matter that there are no connections. We literally need a millisecond window or so where we can actually hold the database, save connection state, upgrade, restore connection state, and let it go, let it continue. So there's going to be a minimal impact, but the critical part is you're not losing connections. You're not losing connection sockets. Nobody needs to reconnect if they already have a session on the database. So that's the coolest part. And it works with bin logs. It works with SSL connections. So all the typical features are supported through this.
yeah, this is great. I mean, I love the fact that we don't have to pay anything additional. There's no any additional setup, no blue green, new environment. You don't have to pay for any sort of proxy. You just say upgrade it. It goes ahead, upgrades in a few seconds, and boom, you're done. So I mean, you're right, man. This is definitely better than it did get better than blue green. So I stand corrected. All right. Well, so Shogun, I mean, this is great, right? So we got upgraded. Our database is looking pretty. It's on 306. Maybe it's on 307. Whatever is the latest one. It's nice and shiny. What does this new database get us? What is now that I'm on Aurora MySQL 3 from Aurora MySQL 2? Of course, I don't have to pay for that extended support event anymore, right? That's a huge deal. What else? What am I getting?
Yeah, so again, a bunch of different features, and very similar to what Simon showed right now is we want to kind of get away from downtime as much as we can, to stay away from the word, stay away from it in our real lives too. And what we're going to show you right now is again a pretty cool feature. It's called fast restart. And what that does is, okay, so firstly, it's restarts. So these restarts can be anything. If you are kind of doing them manually, go ahead, do it manually too, but we're going to make it fast. And then the other thing is if there's any kind of interruption, right? You didn't plan for it. Maybe the instance class is getting replaced. Any kind of things can happen if to cause a restart. And then it's in the name itself. What we've done with the new versions is we've tried to look at what are the key things that MySQL looks at when it's trying to do the restart. And what came out to be was a lot of time is spent into the buffer pool initialization of your database. That's basically your cache. And what we have done with Aurora is we've added a thing called survivable page caches, which means that we do not have to spend time to initialize that buffer pool for you and give you a lot of time back in doing those restarts. And Simon is going to show us how that looks like.
Yeah.
Yeah,
So
and
if you, I guess this is also applicable if there's like any failovers, because failover is technically a restart, right?
Yes. Yeah. So
yeah,
up to
so exactly
200.
why this is important, right? When you think about a restart, why would I care? It's really any time you have to do a failover, do a configuration change that is a static parameter that you need to restart the engine. Even for updates, though, right? Technically, an update is put a new binary on the server and restart the database, right? New version. So, I mean, restarts kind of factor into a lot of the things that you would typically do, not in just upgrades, but just in regular maintenance of the database and in high availability. So this is something that is improving, a bunch of things across the board. And so, like Shagun said, in Aurora, what we're trying to do is, get out, sort of get ahead of the curve of what you might typically see in MySQL in tricky situations. Like I have a million tables, or I have a database with half a terabyte of RAM, and there's edge cases where it takes a long time to restart. So let's take a look at what this really looks like in Aurora 3, and I'm going to get rid of that window here. But I'm going to put something else on the screen. And so what we're going to see here, it's a side-by-side comparison of a V2 and V3 Aurora in response to a restart request. So here we're doing just a manual restart, but imagine this is anything else. Could be an update, could be HA failover. So here's what we have. On the left, we have V2. On the right, we have V3. All we're doing is we're pinging the database every second, trying to get a connection. And then we're going to simultaneously, at the same time, do a reboot, basically API reboot request on this and see what happens. So again, we're pinging every second, and you're unmuted, Aditya.
Hey, fun. Sorry, so an application is running on the left-hand side. I mean, you're doing a simulation, but in real life, you have an application running on Aurora MySQL 2, you have an application running on Aurora MySQL 3, right? And essentially what you're going to do is you're going to pull plug on both sides from the database and then put it back in.
Yeah. Okay, so perfect. Here what we can see, and this almost never happens, but they both started restarting at the same time. Very lucky for the demo. But yeah, you can see here, we're running on like a 32x large instance, some of the biggest things we can get for Aurora. And so you see V3, what was it, 6 seconds to go down and restart, and that's all there is to it. V2, probably closer to, where are we? Yeah, so it's 52, like 24 seconds.
Yeah. Wow, that's almost 6 times
that's
more.
Basically what it is. It doesn't kind of look that impressive if you're just doing it, using a ping test. But remember, this is the time that you shave off of every downtime, every time the database has to go down and back up. Doesn't matter if it's maintenance or upgrade or configuration change or a failover. So this is really critically important. So like when we're down to like low single-digit seconds, your applications might not even notice. They just reconnect and that's it.
Well, that's fantastic. Well, let's. I want to take a pause and say, if you like the show, if you have any suggestions, let us know. There is a link in chat. There it is. It's on the banner. Take the CSAT survey. The first 50 people will get $20. So you can use it towards whatever projects you're working. If you wanted to check out some of the things that we're talking about here, blue, green, whatever. You can do that. So please go and take those surveys. All right. Well, what else do we have here? I know that a bunch of things have changed. Let me make sure, Simon, this change that we're talking about, the fast restart, this is an Aurora specific change, right? So this is not something that we inherited from community. This is something that we have implemented for Aurora specifically.
Correct. Okay. And you don't have to enable it. All you need to do is you need to be on the version, new enough version that supports it. That's all there is. So again, this is sort of transparently benefiting you as soon as you're on a modern version of Aurora. That's no configuration, no opt-in, no nothing. It just works out of the box.
So what else is new? I know, Shagun, you at the beginning of the show you said optimized. I heard a bunch of things. Tell us all about it.
Yeah. So we hear from customers a lot, right? They want to operate these databases on Aurora MySQL, and they want to do it, kind of save money while doing it, right? Everyone wants to save money at the end of the day. So what we have with Aurora MySQL 3 is a feature called as IO Optimized. It is a configuration for your Aurora cluster. You can change this at any time if you want to. This is available with the newer version, so in Aurora MySQL 3. Now, the fun part of it is I talked about cost. So if you are running an app today that's maybe doing fraud detection, you are crawling a bunch of data on a website, what that ends up doing is it results in a lot of IO. We have seen customers push millions of IOs in a day. And what happens with that is you end up paying IO cost as well. What happens with IO optimized is that you do not pay for IO at all. That goes down to zero. So really what you're paying for is compute and storage with a small uplift that's added when you enable this feature. But other than that, you do not have to pay for your IOs. And a very cool other addition to this is not just that you're saving on costs, but you're also improving your performance, your IO performance very tremendously. And we have a demo to show you that as well.
Oh, nice. Love demos. Yeah. So what you got? Is it Simon? All right, perfect. Let's see the demo.
So yeah, and this one is not recorded, so fingers crossed.
Ooh, praying to the demo gods.
Yeah, so here's what we're gonna do here. And again, so Shagun talked about cost aspects of this, but there is no database discussion without performance, I suppose. So it's not just that it can be cheaper if you're doing a lot of IO. IO performance is really something that directly defines your performance in a lot of cases for the queries, right? So the query latency, assuming you're not going straight out of memory for everything that you're doing, the I/O performance is one of the critical factors that goes into your query latency. So this is also something where the I/O optimized model helps, because it does have optimizations that help reduce latency for I/O requests, and therefore, if you're I/O intensive, performance will also benefit as a result of that. So what we're going to do here is we're going to take one of these clusters here. Let's see which one. All the rights one. Hopefully this is going to take all the rights that we throw at it. But what we're going to do is we're just going to run good old sysbench on write-only workload. And as this is running, and again, this is our obsession with zero downtime, I suppose, again. As this test is running, we're going to go and enable I/O optimized storage model for that cluster live without breaking connections, without dropping any transactions, and we're going to see what kind of effect it has. And we're going to use performance insights for that, so you can sort of see the end-to-end path of what you might do as a database person if you're looking at performance metrics for your database. So let's go ahead.
Yeah, man. As far as obsessions go, it's probably the best one I've heard so far.
Zero downtime for everything. So let me just do this. And again, this is not recorded, so something's going to go wrong.
Don't say that,
I'm going
man.
to go and just prepare sysbench test, and then let's see, run it. So we're going to run on 32 threads. We're probably not pushing it as hard as we could, but whatever. We're getting 20-something thousand QPS. And so what I'm going to do is I'm going to leave it running here and hidden sort of behind the window, but not hidden enough so you can see that we're not dropping any workload. So this is not going to need to warm up because, well, it's just simple enough. We can just go ahead, switch to our console. What are we doing here? We're modifying the cluster. It's a very simple step. So basically scroll down a little bit.
Wait, are we doing this in production?
This is production, of course.
Wow.
It's taking all the rates. If
Well,
you're running
isn't there a meme that says I don't test anything unless if I test it, it's only in production?
No, I might regret it, but I'm confident enough that I'm just doing it like
No,
this.
I guess the point I'm trying to make is that it sounds like you can make it online without actually causing a restart.
And we actually get this question a lot when we say, hey, it doesn't require downtime, and nobody believes us. And because typically changes to like storage layer are one of the most like difficult changes to make. But this is really safe to do. So it is really that simple. So I'm going to choose our I/O optimized model for my cluster and just scroll down, continue, apply immediately. Before I click this, right, we're going to open our performance insights. So again, this is something you can do when you're testing it yourself. There's no internal magic here. So I'm going to just choose my...
yes, another free tool, right? You don't pay for this.
Performance insights, yeah. 7 days data retention free. Is that correct?
Well, there you go. If you're using Aurora or RDS, feel free to use it. There's no charge.
So I already have performance insights enabled on this, and I'm going to just go and do a very brief period. So like last 5 minutes, and it's going to auto refresh for me. And there's also metrics below here that you can see, which are going to like automatically refresh. What I'm going to try to look for is latency, right? Because this is what we're claiming this is helping with. So you can see that we are basically at 5 milliseconds latency on this sysbench workload. So let's go back and just modify cluster. And now it's kicking in the background, changing us to the I/optimized storage configuration. And again, this is just going through, no interruptions. So we're going to keep this on the back and just kind of show you that it's not getting dropped connections, transactions, whatever. Sysbench is a good example for that because Sysbench does not like errors. It will just give up if there's connection errors, and we would see it immediately. So what's going to happen here is it kind of kicks in asynchronously behind the scenes to enable I/O optimized configuration. And what we're going to see here is hopefully a reduction in I/O latency as soon as this kicks in. And again, this is a free tool, Performance Insights. this is actually combined with enhanced monitoring, which is more for like operating system level metrics. But you have like a single pane of glass here that you can look at, and it's just refreshing itself. So if you're bored, you can just stare at your production database all day, if you want, if that's what you like doing.
Yes, that could be another Twitch stream right here.
Yeah, watching paint dry or watching metrics crawl. So yeah, we're probably going to have to give it a couple of minutes. But again, so here's the thing. You can enable it in production, zero downtime, but you can also go back to the standard Aurora configuration, also with no downtime. So the cool part is you can just try it out, see how it impacts your workload, how it impacts your workload.
I already see that line kind of weighing down.
I don't know. Let's might be a.
Well, it is. See, there it is. I see it.
Okay, let's give it another minute. It should go down more than this. If that's all we get, I'm gonna be embarrassed. That's why you record demos. No, it'll get better.
Okay. Okay.
So, actually, good point there. Remember how we started with 23,000 QPS?
Yeah.
This is already happening. You see, we're hitting at 30,000 already. So we're looking at 40%. 30-40% boost on this being enabled. So this is already doing its thing. It's just that probably we need another minute for that to show up on the metric.
But you can see. But Shogun, you said something about there were some changes we made, right? Like, I mean, yes, the I/O doesn't cost, but how is this magic happening? Like, why is it faster?
Yeah. So this, so while this is happening actually with the performance metrics, and now it's kind of taking a minute to show up in performance insights, I can actually also show you on my screen on that cost number that I showed you, and kind of talk about how that is happening and how you can really reduce on cost significantly if you're running an I/O intensive workload. So I'm going to share my screen to quickly show you that CloudWatch dashboard that I have. And if we can get my screen on. All right, so this is my CloudWatch dashboard. What I have here is I have two clusters. One has IO optimized enabled. I'm calling it Aurora IO optimized. The other one doesn't, and that's the one at the top. We pushed around almost 5 million IOPS to these different clusters. And what you need to be looking at is the cost, which is at the very right of my screen. For a cluster that does not have IO optimized enabled, I'm almost paying double, so $1,000. Whereas on a monthly basis, whereas on something that does have IO optimized enabled, I'm only paying half of it. And this is really, again, one more benefit that you get from IO optimized. And like we're saying again and again, it doesn't cause any outage, which means that you can easily come back, go in, look at how your cost is looking like. And that's another cool thing you can see. So it's not that I have enabled IO optimized today. I have to wait a month to see if I'm saving on costs. AWS does provide you with things like AWS Cost Explorer, which are, again, almost auto-refreshing dashboards, and you're able to see those cost savings coming in as you're making them, and then decide if you want to stick to it, or maybe you want to change back to IO optimized.
But it also seems like you're pushing more IO, right? So I see that 4.8 million versus 5.49. So you're pushing more IO, but you're getting charged less. I mean, I don't think it gets any better than that. Oh, by the way, there's a question. When should I consider IO optimized for cost? Is there like a percentage?
Yes. So because there's, like I had mentioned, there's a small uplift that you pay on your compute and storage when you enable this feature. So what we've typically seen with customers is if you are running something and running, again, a bunch of IOs, and if your IO cost is more than 25% of your entire Aurora bill, then this is going to be one feature that you should definitely look at to save some money on it. But like we're saying, that 25% number, you don't really have to stick to it because there's performance benefits here as well. So it just may make sense for you to go ahead, enable it, try it out, and then decide if you don't want it, you can again go back to that standard configuration.
It sounds like the more you use IO, the more you save, which is great.
Mm-hmm. Yeah, that's
all right.
Exactly.
So awesome. So I think hopefully your lines are doing better. Simon, let's take a look at your screen.
Let's take a look at my screen. And we kind of already started trending in the right direction when we started talking about Shogun's dashboard. But you can see this going pretty well for not just the latency, but if you're pushing writes, your throughput is the inverse of your latency, right? If you can do IO faster, you do more of it within a unit of time. So we went from 5 milliseconds to 3.2, pretty good, and the throughput also went up. That is reflected in the actual workload behind this window. So it's not that you have to start with cost whenever you're looking at this. Maybe performance is just worth it all on its own.
Yeah, this is fantastic. So almost half the latency, so reduce the latency by almost 100%, 50%. IOPS go up, and then you pay less. This is a win-win scenario, right?
So and kind of key point here is we're talking about write path, right? For performance specifically, we're talking about the write path performance. For reads, it's not going to be this kind of effect because the read path is using a different kind of way to interact with storage. So this is specifically optimized for write heavy workloads. So like if you're importing data, if you're actually doing a lot of these traditionally hard to scale workloads where there's like tens of thousands of small transactions and latency is everything, that's where it will come in. For reads, not so much, but for write intensive workloads, this should be great.
Yeah. So how often can I make this change? There's a question.
Right. So you
can I just turn it off when I do those bulk loads and then turn it back on?
Yeah, not anytime. You can enable it anytime you want, but you can go back to standard storage once in the 30-day period. So if you have 1 day of heavy workload per month, no cheating there. Like you can't switch it back and forth every hour depending on how the workload is looking. But it's not a permanent commitment, right? So like you can run it for a month, see if it works, but you can't switch it back and forth arbitrarily at any time.
Okay. Well, this is great. I mean, there's lots of goodies here. There are lots of, Aurora specific goodies. But, I remember that when you go from, like, when you do these upgrades, when you go from one major version to another major version, there's always something, right? Like the way the queries work, the profile changes. What can we expect in those terms when you go from Aurora MySQL 2 to 3?
Again, this is performance, right? So queries will generally benefit from the generational improvements from one major version to another. But really what databases are in terms of changes in major versions is that the change in behavior is not going to work the same way for every query out there. There is a possibility, and it happens quite a lot that especially like highly optimized workloads would have queries built specifically for the capabilities of the current version that they're on. So like especially the more advanced database engineers would know exactly how a version behaves, and they'll tune their queries for that version, for best results. But what that means, if you're going to another version, you might actually see a different behavior for your queries, because what's going to happen, and I'm going to kill this workload because it's distracting. But yeah, you get the picture. What's going to happen is the engines will behave differently because they have different capabilities in the query engine, in the query optimizer, in the query execution engine. So what it looks like, this is kind of nerdy, but basically what it looks like is you're going to have these capabilities which are, optimize your behaviors in a database that will be different between different major versions. And here I just highlighted a couple of differences between Aurora 2 and Aurora
before
3.
we go there, I know that in older MySQL versions, the schema wasn't crash safe, right? So if you made some changes, it would go to... So I mean, there are some additional really like day and night changes that can potentially also make some performance changes.
Yeah, so, this is a very long story, but yeah, in version 2 in MySQL 5.7, basically, it's like a database inside of a database. So there's the MySQL dictionary layer, there's the InnoDB dictionary layer, and they have to stay in sync. It sometimes leads to issues. In Aurora version 3 and MySQL 8.0 and beyond, this is sort of all standardized into a single transactional dictionary. Which also means that the objects that you have in a database have to be sort of converted to that dictionary when you do the upgrade, which is another reason why you use stuff like Blue-Green. So like if you have 1 million tables in a database, you need to convert them between the dictionaries. Blue-Green lets you not care about how long the database upgrade takes.
Yeah. Okay. Well, I mean, it sounds like I want things crash safe, especially if I'm on a relational database. So that makes perfect sense.
Yeah.
All right. Sorry about that. Let's go look at the optimizer switch thing.
Yeah, so you hopefully won't have to look at this too much if you're upgrading. Hopefully the queries are, net same or faster than they used to be. But again, the query optimizer behavior is heuristics. Basically, it doesn't know exactly what the best way to execute a query is. It's just trying to estimate it based on statistics and based on the sort of behaviors that it supports in how the queries are optimized. So basically, there's differences between the versions, and it has typically there's new and new optimizations coming in new versions. But what that means is the queries will essentially sometimes behave differently. So what is going to happen is what you're going to see is what we're doing here, for example, we're just manually disabling and switching optimizations that are different between versions. And this is basically the same query, but there's just two different optimizations being used. And you can see that the impact on the query time can be quite significant. So in this case, the
It's
query
almost
basically
three times.
literally became twice as long with
Yeah.
a particular optimization disabled. So the good thing about this is all of these things are switchable um, at the query level, at a table level, at the entire cluster level. So you're not locked in. All you need to do is essentially just find out which queries are potentially getting slower, and you can do it with performance insights, which is giving you the top queries, the longest queries, or what have you. Or you can pull it from query logs, wherever you want. Once you have a query that is a subject of your investigation, you can just pull a query plan, explain it, and see if by switching those knobs, the query plan becomes better or worse, or whatever it is, right? So at the end of the day, you start with queries, you compare them, you compare the execution times, and then you adjust these differences in the optimizer switches to get the query to where it needs to be. It doesn't always, it's not always just enough to do the optimizer switches. Sometimes you just need to kind of work with the queries also to just adjust them to the new version. But that's kind of where you start. And again, with tools like Performance Insights, you don't have to like dig for it. It's right in the dashboard. You can see it right there.
And Shagun, it sounds like having a blue green is really going to be
Yeah.
important here.
Yes, yeah. So exactly things like Simon mentioned, running profiles, running explain on your SQL statements. You can do that in the green, and then you can easily get a comparison of how it looks like on the blue side as well. Run explain over there. MySQL 8 also enables explain, analyze. They support explain, analyze as well, which again gives you more information on what is that exact step in the query where it's spending a lot of time. So explain, analyze, profile, those are all things that are going to be helpful to understand how my query behavior may have changed with going between these versions.
Yeah, and so with blue green, you have these side by side versions, so you can always go back and forth and see how those
Yeah.
changes affect. It
Yep,
sounds like
absolutely.
Simon, you want to show some additional things here. I'm sorry, I'm
Oh
rushing.
yeah,
We're almost
it's
at
just a
time.
real quick. So we just came back to the same dashboard we saw before, but instead of looking at metrics, you can look at queries, users, hosts, and this is basically what you're looking at. You have the exact query patterns, so you don't even have to do the things that you used to have to do with like slow query logs. Oh, I terminated the workload and it's gone. Of course,
It's
I'll
all
run it
right.
again. I'll run it again. But basically, and like you would traditionally have to go through like slow query logs, log a bunch of stuff, dig through it manually. But with this, you don't have to do that anymore. It shows you the queries right. Oh yeah, I just ran it 10 seconds ago and it's already there. So that's as simple as it is. You see the queries, you see how long they take, everything is there.
Yeah, I know our customers love Performance Insights. It's free. It gives you a nice visual breakdown of everything. There's just really no reason to not use it. So, well, excellent. I think I'm pumped to take advantage of all these. You've convinced me. Take advantage of all of these shiny new features. Let's go, everybody. Let's go get those Aurora MySQL 2 upgraded to Aurora MySQL 3. Don't pay for that extended support. Take advantage of all the new features. Use Performance Insights. Use Blue Green, and then take advantage of the zero downtime patching, downtime restarts, all that kind of good stuff. Don't forget to take the survey. First 50 people, you're gonna get $20 on your as AWS credits, so you can have some fun and maybe spin up some databases and see how this all works. So just as a reminder, we run this show every other week. So if you haven't heard enough about upgrades, we will have some of the same people come and talk to you about RDS upgrade. We talked about Aurora upgrades. We're going to come back to you on June 27th at the same time and talk to you about RDS upgrades. So don't forget to tune in. And thank you all for attending. Take those surveys, and we'll see you again soon. Thank you, Shagun. Thank you, Simon. This was
you.
fantastic.
Thanks, folks.
Thanks. Take care. Bye.